A project for CSCIE 90 cloud computing, fall 2014 at Harvard University Extension School under Prof. Zoran Djordjevic. Subject was AWS Android SDK. We use it to solve a problem that occurs in emergency rooms, which is the late activation of emergency room staff. So our summary, we basically discussed what the impact of heart disease and the burden that it poses on the U.S. We explained quickly what a heart attack is, what are the goals for the current project, the current environment, the solution that we designed, and what are the benefits, the challenges, and the platform, also the setup, and then what does the technology do, and also the pros and the cons of the technology. We also discussed some possible extensions. So the U.S. heart disease burden is the #1 life-threatening emergency, #1 cause of death. 600,000 people, 1 in 4 deaths every year, for a cost in loss of productivity, medical cost of $108.9 billion every year. So what is a heart attack? A heart attack is when the heart muscle dies because of lack of oxygen, and is usually recognized by paramedics outside of the hospital. The American Heart Association says that the early and rapid identification, notification of medical facility, and intervention are critical to prevent death or irreversible partial full heart damage. So our goal was to develop a program using AWS SDK for Android to help healthcare providers speed identification, notification, and intervention, save lives, improve surviving patient outcomes, and save at least one of those $108.9 billion. So what is the current environment? In the current environment, the paramedic responds to a call in the field, could be anywhere. They assess the patient, provide immediate life-threatening medical care, and if they recognize that the patient is having a major cardiac event, they will get on the phone and call the phone attendant at the emergency room. The phone attendant will then try to connect them with a doctor, who of course is just sitting there waiting for the call to arrive. The paramedic will actually talk to the doctor and describe what they have on hand, and the doctor will give them a feedback, and based on the conversation that they had, the doctor will activate the cardiologist. Keep in mind that ER doctors are very busy, but cardiologists are even busier because they are actually short-numbered. So they don't want to be activated all the time, or because it's just so few of them. So what are the problems with the current environment? So in the current environment, the paramedics who are less trained than the doctors and the cardiologists are the one making the decision in the field of who has to basically get emergent treatment in the emergency room or in the operating room. The doctors are busy. It's hard to get them on the line. Sometimes the calls get disconnected. And worst of all, it's a verbal dialogue between the doctor and the paramedic in a chaotic environment on both sides. Also, while the paramedic is talking on the phone, obviously he's not delivering as much patient care. So this communication is basically a synchronous unicast verbal communication in which both people, actually 3 people, have to be available at once for the phone call to occur. There is limited verbal information, limited feedback that is provided, and the emergency room doctor has to basically tell the cardiologist what he heard from the paramedic. So the cardiologist, who is actually the one performing the procedure, gets third-hand information. So what we are suggesting is a much simpler and flexible and also faster environment, where the paramedics do not attempt to call the hospital. All they do is, after they're done collecting patient information, they wirelessly transmit that information to a cell phone using Bluetooth or any other, uh, local network technology. And from the phone, our application will allow them to hit the patient file and send a notification to a topic, AWS topic, that will immediately publish or actually distribute the notification to everyone who's signed up, who's subscribed to that topic. And everyone in this case could be the ER doctors, the cardiologist, or anybody else who may need that information. Obviously, from a topic, you can send information in different formats to the subscribers. So what are the benefits of the new environment? It's asynchronous. In other words, the paramedic doesn't have to stop what he's doing to try to get a doctor. And the doctor doesn't have to stop what he's doing to talk to the paramedic. The paramedic can just hit send, and the doctor will get a page or SMS or an email, whatever format is decided. And the doctor, depending on what he's currently doing, may delay for a few seconds looking at the message. It's easier, it's faster, both back to work quicker. We have the advantage of paging. We can page multiple doctors for consults. There's a much accurate feedback because obviously the doctor gets the full file of the patient. And same for the cardiologist, who now doesn't rely on third-party information or third-hand information, but rather can actually look at the patient's file himself. This will allow the emergency room doctor and the cardiologist to pre-plan for when the patient gets there. So we use the AWS Android SDK to develop the program. And we just have a diagram to show where it sits in the infrastructure of AWS. So at the bottom, we have, from the bottom going up, AWS Global Infrastructure, which is basically the network and the servers and everything that is at the physical level. And going up, it's all organized into regions, foundation services, application services, and then deployment and management. Basically, AWS SDK for Android provides APIs to our applications so that they can actually access and call and use all AWS services. So in AWS language, we have the solution that we designed. So paramedics, they use a mobile client. They will upload the patient file to an S3 bucket, and they will also send a notification to SNS topic. The notification to the SNS topic contains a link to the S3 bucket file, to the patient's file in the S3 bucket. And then that information can actually be sent to paramedics, ER doctors, cardiologists in different formats, as a message, as an email, as a HTTP endpoint, or just sent to a client computer. So the environment that we use to develop Android obviously has the largest mobile base, and AWS was the primary tool that we use in class. The SDK provides APIs to AWS services on the Android platform. Setup is straightforward. We install basically Android Studio, and then we add AWS SDK for Android libraries to the IDE. So Android Studio basically includes our application and also Android libraries. So Android Studio is relatively new compared to Eclipse, and it's the official Android IDE. And it is recommended for people using Eclipse and ADT plugin to migrate to Android Studio so they can get the latest IDE updates. It's built on IntelliJ IDE Community Edition JetBrains, flexible Gradle-based build system, and a lot of features that make it easy to develop very powerful applications. So the AWS SDK comes with full APIs documentation, The lib folder contains a core jar and jars for the major AWS services. We have source and samples in GitHub repositories. It also includes third-party libraries such as Joda or Jackson. License notice and README files are included. A logging.html file shows us how to tweak the logging with the SDK. So development environment, we talked about that already. So as far as our result, so the main menu of our application, basically we made it very simple as a prototype. Obviously, we would have normally a logging screen because of HIPAA and all the health rule and laws and statutes to protect unauthorized access. But in this case, we just had a simple menu with buttons for paramedics, ER doctors, and cardiologists. So a paramedic can alert an ER doctor can alert a cardiologist, an ER doctor can send a feedback to a paramedic, and a cardiologist can send an emergency room feedback. So from the main menu, if I was a paramedic, I would hit alert ER, and my next screen will actually show a list of patient files, including a 12 lead EKG, which is the primary tool for diagnosis or identifying the connection of heart attacks. That list is scrollable, and paramedic will scroll to pick the patient that he wants to notify the emergency room about. And also, just a tapping on the patient will actually trigger an upload of the patient's file to an S3 bucket, and the sending of the notification to the particular emergency room distribution list. And as you can see on the right hand side, the doctor will receive a page. We don't have the screen of the page, but if the phone, let's say, was on the main menu, maybe it was locked, then we'll get a page and a notification at the top of the screen. And then after a while, that notification would fade away and will become like the number of messages at the bottom of the screen. But opening the message, that's what we see. What we see is basically the hospital emergency room, a link to the patient's 12 lead EKG, the patient's file, and then a full description of the patient, vitals, and current status. So from the main menu, that link is actually not correct. It should be from alert cardiologist, which is the second menu, to opening that window that allows the ER doctor to alert the cardiologist. So he will basically type what he needs. Does he want what part of the cardiology department he wants to activate? It could be the operating room or the cath lab for catheterization, stent, cardiac bypass. So he will basically put in quickly what he needs, and he will hit send. And on the other hand, Fairfax car, which is the topic that belongs to which the cardiologist has subscribed, will get a notification and will distribute it to all the cardiologists to tell them there's a need to activate the cath lab or the operating room. So as a conclusion, AWS SDK for Android is a great tool for mobile app development. It is well supported. Plenty of support is available. The emulator works well, a little slow. There's a seamless integration of a real device to the USB port. And you may want to read login.html to learn how to tweak login with the SDK. Thank you for your attention.